There's a lot of benefits for using simulation to validate our designs. However, sometimes when we're dealing with things that have symmetry, we can actually do things a bit more intelligently by representing them using 2D simplification. If we look at applications like seals, O-rings, latches, clips, those sorts of things, typically there's a form of symmetry to either the shape as well as the loading. And if we can represent that as a slice and just give it the thickness, then we can be a lot more efficient and get a solution a lot quicker. Now in SolidWorks Simulation 2011, in the professional version, we've added a new capability to support linear, thermal, and nonlinear applications. And there's going to be a lot of value for that. But let's look at how much value there is. Now if we look at modeling things as solids, the challenge we have is it takes a lot of elements to get a very refined model. You can see here, just with the default settings, you don't get that much refinement through the thickness or in small elements such as these seals here. However, if we can model that as a 2D slice, you can see by default we get quite a lot more depth of information and accuracy through the thickness of the materials. Let's take a look at how that works from a solution aspect. We can see here for the full solid it can take 43 minutes to run just a simple static analysis. If we take just a slice of the solid and use some symmetry, we get that down to 11 minutes. However, if we use a full 2D slice, we can get 3 seconds and get the answer. But again, look at that, with a lot more accuracy as well. So it's not only faster, but it's a lot more accurate. Let's look at the situation of a nonlinear model. Now, so this instance, it's actually completely impractical to run a nonlinear model on the entire geometry. It would take hours to solve. What we did is a little slice of 20 degrees of the model and ran that as a nonlinear model. Did the same thing with a 2D simplification with a default mesh, and then we did it with even a much more refined mesh. Again, looking at the times, you can see it's almost 3 hours for that little 20-degree slice. So imagine what it would be for the entire solid. For the default 2D slice, just 19 seconds. That's just a huge improvement in performance and accuracy. And then when we go to our super refined slice, again, it's only 43 seconds. But again, the accuracy is so much more than what you could get with solids. And it's not just things of axisymmetric. We can look at things like latches, where what we do is we take a slice through the thickness, assign it the thickness values, and we can get, again, much more accurate data. Versus a solid model, even a refined solid model, you can see the solution times are drastically smaller, and again, the level of resolution in the results is just so much more superior than what you can get with 3D. So the important thing to remember with 2D simplification is that it's not only doing things quicker, but it's also giving you a much more accurate result that you just cannot get with a 3D model. Let's take a look at that inside SolidWorks. So here's the seal system, and the process for doing a 2D simplification is very straightforward. We select the type of study we want to run, and then we just check the 2D simplification option. Then we get the option of how we want to look at the analysis, and we've got 3 options. For things that are fairly thin but of constant section, we can use plane stress. For things that are like a long extrusion, like a dam wall, if you want to just do a study on that, you can use plane strain. And then we have axis symmetric for something that's a revolved body. So we're just going to pick this plane that we want to do a slice through, and then an axis of revolution. And we get a slice done very quickly. You can see it's updated that pretty instantaneously. It brings across the material properties from our geometry straight away. All we need to do is a couple of things. First, I want to define contact that says these seals can't penetrate the solids. So I'll just set those up. And again, everything's based on geometry. So if the geometry changes, all these locations for fixtures and contacts also change. So just fix it at the bottom. And then we're just going to pull down on the top of the lid and do it 10 millimeters. Now if we want to do a refined result, do that, we can add a mesh control, and just pick these seals since we're more interested in what's happening in the seal. And one of the things we do have in 2011 is the ability to toggle symbols on and off with one go. Let's just create the mesh to see what that looks like. And again, the great power of 2D simplification is in the speed as well as the accuracy. So you can see in just a couple of seconds we're going to have results back for our analysis, which we can animate, but some people find it hard to look at a section to interpolate, so we've provided the ability to take that back onto the 3D geometry. So we'll do it on a half of the section, and there's our profile. So it makes it a lot easier for people to understand what's going on, and of course we can animate that as well. And as I said, the same thing with when you want to take into account the nonlinear rubber is that again, the solve time is very quick, and again the results are very accurate. Now, what about a change? Again, I mentioned it was parametric. Let's just see how that works. Let's just change the height of this to 500. And you'll see when we go back to our profile, it's automatically updated. Just click on Run. And again, matter of seconds, we've got a new result. So it's incredibly quick and efficient, and as I said, it's a lot more accurate. Look at the latch system. In this case, what we're interested in really is the latch closing over this pin, and we can do it by accounting for the thickness of the latch. And again, it's just a matter of seconds. We can run the study and get the analysis out. So we can animate that so you can visualize that. So we can come in here and really optimize the thickness of these arms here to ensure that it doesn't require too much force to lock onto the latch. So it's a very powerful tool to enable us to understand lots of different applications very quickly, very efficiently, and also very accurately.